the SensoPart FT25BH, a sensor designed to detect pretty much any surface. In this section today we're going to be looking at dark or shiny objects. We take this dark cloth to start with. We can see that both sensors are detecting this, but as we get close the red light has a little bit of trouble with a blind spot up close. Now if we start to look at the other side of the fabric, which is subtly darker, and starting adding in angles, we can see that there's just not enough energy coming back for that red light to keep the trigger, whereas the blue light is staying solid even with a really sharp angle there. And as we flicker the material around, we can see the blue light stays steady, whereas we're getting quite a lot of flicker on that switch for the red light. This is really quite impressive for a diffuse sensor, looking at those sharp angles here. Now if we take a shiny plastic product, this is typical of the plastics industry, and if anyone works in that industry you would have known that red light can struggle with this type of product. As you see, even a kind of a 5-degree angle there, the red light sensor gives up, whereas the blue light sensor stays on continuously for that entire time. Really quite impressive for such a shiny black product there. The next product we look at here is still a bit shiny but has some texture to its surface, maybe a little bit darker, and as we bring that in we can see again the red and the blue light trigger fine, and as we add the angles the red light just can't get that energy back to keep the trigger going. The blue light, even with those really severe angles there, is still getting enough energy back to detect that, and again that subtle blind spot for the red light as it gets close. Any kind of plastics, materials handling, whether it's on a conveyor belt or robotics application, this will be really useful. Now let's imagine looking at a cylindrical object. As we pass this across the front of the sensors, we seem to be getting one trigger from both, so we're pretty happy with that. As we slow it down, we notice that the blue light is triggering much earlier, as it's seeing right from the very edge of that part, whereas the red light is truly only seeing the flat front face of that part. We show this by giving some angle to this tube now, and we can see the blue light continues to trigger, whereas the red light just gives up. It can't detect that. There's just not enough red light energy coming back for the sensor to detect this product. If we were thinking about a robotics handling application, you might not be sure which orientation the part will be presented to your gripper. This blue light will be fantastic in that type of situation. Finally, let's take the phone screen. Looking at this now, we can see that both sensors, when it's dead straight, will detect, but even a 5-10 degree angle, the red light gives up and just can't see that. Whereas again, the blue light sensor is triggering fantastic. So in maybe a manufacturing process for producing phones or solar panels or that type of application where you might have such a shiny, deep, dark black surface, this blue light is going to trigger every single time, which is absolutely amazing. Thank you very much for watching the video. Please check out the other video which shows the blue light sensor, this same one, working with transparent objects.